Welcome back, students. Today we will solve one more gate problem. Three numbers 11001, 1001 and 111001. They correspond to the 2's complement representation of which of the following set of numbers that we need to determine. Before we solve this question, let us understand one very important concept. Let us take one example. Let our data be, suppose we'll take one example, and let us suppose my data is 1011. So this is the number I have taken, and let us find its 2's complement, because the question is based on the 2's complement method, and I hope you would be knowing how to find the 2's complement. Those who don't know, I am telling there are two steps. First one is we invert all the bits. We will invert all the bits, and next thing is we will add 1 to that answer. We will add 1 to that answer. So if we invert all the bits of 1011, it will change to 0100. So what I have done, all the bits have been interchanged. So 1 has become 0, 0 has become 1, and so on. And now we have to add 1 to it. So if we do plus 1, so it will be 0101. So we can say that if we have to find the 2's complement of this number, which is 1011 originally, it has become 0101, right? Clear? Now what I will do in the next step is I will take this number 0101, which I got from here, and I will again find its 2's complement. I will again find its 2's complement. So again I have to use these two steps. I will invert all the bits first of all. So if I invert all the bits, let me do it here. It will be 0101 by inverting all the bits, and then in the second step we have to add 1. If we add 1 to it, it becomes 1101. So what is the 2's complement now? We got 1011. Now what have we learned from this example? We started with a number which was 1011. We got its 2's complement, which is 0101, and for the same 0101, when we are again finding the 2's complement in the next step, we again got the original number back. Correct? We again got the original number back. So the conclusion from this exercise is that I will note it down. Finding 2's complement of a number gives original number back. Original number back. Okay, this is what we have concluded. If suppose 2's complement is given and you are again finding the 2's complement of that, it shall give us the original number. Now if you will read the question again, you will find out the three numbers that are given here, they are nothing but the 2's complement representation. So if we will again find its 2's complement, that should give us the number back, correct, if we extend this concept here. So what I will do now, I will take all the three I can say numbers being provided, and we will find their 2's complement again, and we shall get the original numbers behind all the three. So let us do it. So the first number is 11001, second number is 1001, and the third number is 111001. So we have to simply find out the 2's complement, right? So please find the 2's complement of all the three by using these steps that we have done over here. If we do it on the first one, you invert all the bits, it becomes 00110, and you add 1 to it, it becomes 111. Similarly, if you see the next one, you invert all the bits first of all, it becomes 0110, you add 1 to it, it becomes 0111. And if you see the next one, you invert all the bits, it becomes 011 with 000, and you add 1 to it, it is again 111. And 111 you all know, it is nothing but the 7. So the answer to this question is -7, -7 and -7. The answer is C to this question. Now why is it minus 7? Why is the answer minus 7? Because we know that as far as the complements are concerned, complements are always found for which number? Negative number. If the number is positive, then there is no need to find the complement, because then we can use the simple addition rule over there. So that's why the answer has to be negative, and C has to be the right answer to this question. So that's it for today. I will see you in the next video. See you all. Take care.